You can start the session, ma'am.
This week, so good evening, everyone. Okay, so is my screen visible? Am I audible?
Yes, ma'am.
Okay. So till the last class, whatever I gave you the PDF also. So everyone has gone through the PDF. Is there any doubt, any question, anything you want to ask me? Anything, whatever we have learned so far in thermodynamics, does anyone have to ask me anything? No, right? So can we just start with the, please remove this. Can we just start with today's class? Whoever done this, please remove this first. Yeah, good. So let's start with the today's class. So what is free expansion? So today we will be learning about free expansion. Okay. So free expansion means this was the system to us so far till the red thing. Okay. This was the system so far. But now this system, like the container with a piston and an ideal gas, this was the system so far. But now this whole system is being kept inside an insulated container. Okay, so did you understand what I told just now? That this was the whole system, this red part, and now this system is kept inside an insulated container. Now they can ask you what is the work done by this free expansion. So we need to calculate the work done for free expansion of gases. So we need to calculate work done for free expansion. What is the formula for work done? Minus P external dV. Okay, or delta V, whatever you write. But here, this P external remains 0. Okay, obviously you can say, ma'am, you are pressing, it is not being pressed, but this gas can exert a pressure on this piston. Yes, of course they do. But we always calculate the work done for external process. Now, here you can ask me one more thing that, ma'am, during the calculation of work done in irreversible process, we calculated the P external with P internal, because there we considered the P internal in that case because P internal is almost equal to P external in those system. That is in the reversible system. P external gets equal to P internal, and that is the reason we considered P internal for calculation of work done for reversible process. But except that system, we calculate work done in thermodynamics considering the P external only. P external is 0 because we are not pressing it, not this gas is doing anything. So the work done will be 0. Is this part clear? And also insulated container means Q will be 0. That means the heat is neither being gained nor being lost. Is free expansion clear to everyone? Yes or no? Or else I can just move to the next sum. Then we will be starting with the numericals. So is this part clear to everyone? Mute and say, please. Is this part clear to everyone?
Yes, ma'am.
Okay. Please be interactive in class. Now, starting with the sums. Today we will be doing 7 sums, and from these 7 sums, you will be solving each and every question from the first law. So our first law and everything will be 8. Now, what is the question is saying? PV plot for two ideal gas during adiabatic process are given below. This is the adiabatic process growth curve for two gases. A and B. What is this A and B? This is for gas A and this is for gas B, and this is the PV curve. Now they have asked you what are the probable conditions for what are the wait. Yeah, so they have actually asked us to calculate to tell us what will be A and what will be B. Now, how to solve these questions? We know PV to the power gamma is equal to constant. Last class, we derived this. So, when gamma is more, then pressure will be less from the derivation. Can we say from this? Can we say from this equation, if PV to the power gamma is constant, it means if gamma is increasing, pressure is decreasing? Yes or no?
Yes, madam.
Yeah, right. So what can we say? Okay, we know it is being said. See, now see, helium is a monoatomic gas. Yes or no? Helium is a monoatomic gas and hydrogen is a diatomic gas, right? Again, hydrogen is a diatomic gas, helium is a monoatomic gas. Helium is a monoatomic gas, neon is a monoatomic gas. Hydrogen is a diatomic gas, chlorine is a diatomic gas. Now, what is the value for gamma for monoatomic gases? From the chart, tell me what is the value of gamma for monoatomic gases and what is the value of gamma for diatomic gas?
1 and 2.
Yeah, so it is 5/3 and this is, I guess, 7/5. Okay, 5/3 is roughly equal to 1.66 and 7/5 is equal to 1.4. Okay, so which is more? Gamma monoatomic?
Yes, ma'am.
Wait. So gamma monoatomic is more than gamma diatomic. And from this equation, what can we say? Pressure for monoatomic will be less than pressure for diatomic because this is a reverse condition. Yes or no?
Yes, ma'am.
Yeah. So, where the pressure is less, B is pressure less and A is the pressure more. Right? In this
Yes,
picture,
ma'am.
this is up. This is a normal PV curve. So, which is up? A is above B, right? So, A has more pressure than B. So, from given diagram, A has more pressure than B. And if A's pressure is more than B, so what will be A? A has to be diatomic and B has to be monoatomic. Right or wrong?
Yes, ma'am.
So if, yeah, say.
A has more than pressure than B. Then can you tell me why did we A, why did we the A will be diatomic and B will be monatomic?
Just repeat your question once because your voice is cracking.
Ma'am, I'm telling that A has more than pressure than B. Is it considered from the monoatomic is greater than diatomic?
You want me to explain this step?
Yes, ma'am.
See, this to this is clear to you.
Ma'am.
Okay. Now you told me that gamma. Now, why I have considered only gamma for monoatomic and gamma for diatomic? In your option, see, this is a monoatomic gas. This is a diatomic gas. This is diatomic. This is monoatomic. Monoatomic, monoatomic, diatomic, diatomic. So I need to know gamma for monoatomic and diatomic. Okay, so I have calculated it from the last class table. Okay, so from this, what I can say, gamma of monoatomic is more than gamma of diatomic. Can we see it from this statement? From here, can we write this statement? Yes or no, say? Whoever asked the doubt.
Yes, ma'am.
Okay, so, and you already told me from this equation, I can conclude this, that if gamma is less, pressure will be, if gamma is more, pressure will be less, right? Here, gamma is more than this gamma. So, this pressure will be less than this pressure. Is this now clear? I got it from this statement. I'm concluding from this. Is this
Yes,
part
ma'am.
clear?
Yeah.
So, now from this diagram, check. From this diagram, this A has more pressure than B because A is above B, right? And if the pressure of A is more than B, so what is this? Diatomic. A has to be diatomic, B has to be monoatomic, right? So A has to be diatomic, which is helium, and B has to be hydrogen, and B has to be monoatomic, which is helium. Okay. If in your question they asked you B and A will be, that will be helium and hydrogen. So just check the order what they are asking. So is this whole numerical clear to everyone?
Yes, ma'am.
No doubts, right? So last class, before starting degrees of freedom, I told you that this has to be an isothermal process and this has to be an adiabatic process. So do you remember? Last class, in my notes also I have written that for this has to be, A has to be an isothermal process and B has to be a okay, let's forget about that. Let's forget about this, whatever I'm saying. This sum is clear to everyone? Yes or no? Okay, let's move to the next sum. Now, reversible expansion of ideal gas under adiabatic and isothermal condition is shown. Choose the correct answer. This will be multiple answer. How to solve this? Remember, in the last class, in my last class, before starting degrees of freedom, I gave you a graph like this and told you A has to be isothermal, B has to be adiabatic. And I told you I will be explaining you later why the curve above is the isothermal curve and why the curve below is the adiabatic curve. Did you remember? Or else I have to just move, like I have to scroll. Did you remember? I have told you in the last to last class, before starting the degrees of freedom, that, okay, let's just see. Yeah, I told you. But where is it? This. I told you that the curve which is above will be isothermal, the curve which is below, it will be adiabatic. You guys are not revising. If you're not revising, I don't know what you will do in your exams. Anyways, okay. So let's do with this sum. I'm telling you repeatedly, just please and please, just revise and practice whatever sums I am making you do. If you practice this regularly, you will be getting good marks. If you really want to crack JEE or NEET, or else you can just not solve, no issues. Okay, so what I was saying is that, so from this, from the previous class notes, I can conclude that A is isothermal, and B is adiabatic, right? Is this part clear?
Yes.
Okay. Now, what is the first option saying? T1 is equivalent to T2. What is T1? This is T1. What is T2? It is T2. Where this T1 and T2 lie? On curve A. And curve A is an isothermal process. We know in isothermal process, everything remains constant. In isothermal process, temperature remains constant, right? So obviously T1 will be equivalent to T2. Is this explanation clear? Right, like this. Since both T1, T2 lies on curve A, and we know curve A is isothermal. In isothermal, what is isothermal process? Temperature is constant. Temperature is constant. So this option will be correct, right? Is this part clear?
Yes, ma'am.
Everyone? Okay. Okay. Now, considering this, T3 is greater than T1. Now, in my last class, while making you do a sum, I told you this. Wait. Where is the sum? This. Temperature decreases in adiabatic expansion. The adiabatic expansion can be reversible or it can be irreversible. This is the conclusion I have already drawn in the last class. Okay. So, what it is being said in this question here? In this question, the arrow is like this. It means this is an adiabatic expansion process and an isothermal expansion. Both are expansion process. And just now I told you that temperature decreases in adiabatic expansion. So this is a false statement. Is this part clear? Why did I mark this statement false?
Yeah.
Yes, now. Okay, for this. What is this? W of isothermal greater than W of adiabatic means they are considering the work done, and we know for work done we calculate the area under curve. So let's just do this. Okay, for this now any one of you can say me, ma'am, area covered by the curve A. What is the area covered by curve A? Wait, let me do this. What is the area covered by curve A?
B plus Y. B plus Y.
I am solving it here, okay? How to write like this? Okay, I am solving this question above. Area covered by A. What is that? Blue
B
plus
plus Y.
blue plus orange?
Yes, ma'am.
Yeah. So area covered by B. Only orange. Right. So now you can tell me, ma'am, so work done of the isothermal, and A is what? Isothermal. I'm not writing it isothermal, and B is adiabatic. So you can tell me, ma'am, yes, this statement should be correct. But what is the basic formula for, and I told you that work done, remember this, work done in expansion, you always get this value in negative. Okay, for expansion, you always get the work in negative. For it, this is something we have learned in the sign convention. I am not going back because it will take me a whole year to go back. What we have taught, that work done on system is the compression work, right? And you get this value in positive, and work done by the system is the expansion work, right? And you always get this value in negative. Now you can tell me, ma'am, so we use the basic formula of minus P external delta V, right? This is the basic formula we use to calculate work done. So if I see in the question paper that work done is on the system, should I consider it as plus? No. No. You will always use the formula minus P external delta V. In your answer, you will automatically get this value in plus. And for the work done by the system, you will use the same formula, minus P external delta V, whatever formula I have taught you. But you will automatically get the answer in negative. Is this part clear? Is this part clear to everyone?
Yes, ma'am.
Okay. So what is this? This is an expansion word. So whatever value we are getting in negative. We will get this answer in negative. We will get this answer in negative, right or wrong? Sorry, wait. Sorry. Okay. So now we know about the area covered. So work done by A or the isothermal process is negative of the blue plus orange, right? And work done by B, that will be negative of only orange. Okay. So now, to make you understand, just to make you understand, okay, I am considering a value. Okay. Suppose this blue plus orange together is 5. Okay. And this orange, this value is 3. So this is negative 5. This is negative 3. Now you tell me among negative 3 and negative 5, which is bigger? Can I write like this? Is this
Yes, ma'am. Yes,
so
ma'am.
obviously this statement becomes false. It is a false statement. Okay. Now, in your exam paper, for this question, they can write you like if this is written, then this statement will be true. Why? Because whenever these two signs are given, they are just saying about the values. They are not considering the negative value. Okay. So, you will always calculate the work done. I have taught you about calculation of work done. For isothermal process, reversible, irreversible, for everything I have given you a formula, right? Adiabatic, isothermal, polytropic, and anything. I have taught you those formulas. Yes or no?
Yes.
Yeah. So whatever formulas you are using, don't change this value. Okay, don't write plus and minus. Just remember that if in your exam, the question is given as compression work or work done on the system, you will be getting your answer in positive. And if it is given by the system, you will be getting your answer in negative. No need to consider here plus or minus. Okay. You will be automatically getting your answer in positive and negative. Whatever the formulas I have taught you for isothermal, adiabatic, reversible, irreversible, use exactly those formulas. Okay. So up to this, is this sum clear?
Yes, ma'am.
Yeah. So now say, what is this delta U? See, delta U isothermal is 0. We have learned. Delta U for isothermal is 0. And delta U for adiabatic is what? Delta U, see, I'm telling you for adiabatic process. Q plus W, Q is already 0, so it is work done by adiabatic process. And what we have learned, this is an adiabatic expansion. And what I told you just now, in expansion, you will get the value in negative. So obviously, this value will be negative. And 0 is always greater than negative. So this is the correct statement. Okay, so this is a correct statement, true statement. So is this whole sum clear to you? Just see and just let me know. Is this whole sum clear to you?
Ma'am,
Yeah,
once explain the option D.
option 2. Okay, delta U for isothermal is 0. I have previously taught you in the class also a lot of times. Now, how to calculate delta U? Delta U means Q plus W, right? From first law of the thermodynamics. And Q is 0 for adiabatic process. Q is 0 for adiabatic process. We know this. So delta U is W. So W means adiabatic. So delta U is equivalent to work done in an adiabatic process. And work done, what is the adiabatic process here? B is the adiabatic process. See, arrow is like this. So it is an adiabatic expansion. And I just now told you for expansion, we will get the values in negative. The answer will be negative. So this is 0 and this is something we are getting in negative. So 0 is greater than negative. So this is a true statement. Is this part now clear?
Yeah,
Yes,
ma'am.
ma'am.
Everyone, is this part clear?
Yes, ma'am.
Okay. Now, this question. A heat engine carries 1 mole of a monoatomic ideal gas. Find QAB and QCA. What is this? What is heat engine? How heat engine works? This is something you will be learning in physics. Okay, but we just need to calculate this. We don't need the concept of heat engine. In last to last classes I've taught you one thing. See, we have to calculate QAB. First, we need to calculate QAB. What is AB? This is AB. Okay. AB is parallel to P. Right or wrong? AB is parallel to P. From the graph. Yes or no?
Yes, ma'am.
Okay, I told you in the last classes also that if something is parallel to something, the other thing gets constant. So, in AB process, AB is parallel to P. So, obviously, what will be the constant here? V is constant.
V is
And V is constant means what process? Isochronic.
Isochronic.
Is this part clear why I wrote isochoric process?
yeah, ma'am.
Everyone?
Yes, ma'am.
Wait. So this is so from this we know that AB is isochoric process. Now, what is QAB? We need to calculate QAB. QAB is delta U. How I have written QAB as delta U, you can find from our previous notes only. Because this is an adiabatic process and, this is an isochoric process. And in first or second class only, I have told you that for isochoric process, Q is equivalent to delta U. Okay. And delta U is in CVM delta T. Right? This is the formula we already derived. Okay. So now, what is N? N is 1 mole. 1. What is CVM? What is the value of monoatomic gases CVM? From the chart, I'm writing it. And what is the delta T? 600 minus of 300. Okay. So whatever you will be getting something R, and the options will be given also in R. So is this part clear to everyone? Is this sum clear to everyone?
Yes, ma'am.
Good. Now, just tell me for CA, what is the thing happening here? So now you tell me, in CA process, what is constant?
P is constant.
Very good. P is constant. And what is P? If P is constant, what is the name of the process?
Isobaric.
Good. So it is an isobaric process. So Q of CA is equal to delta H is equal to N CPM delta T. Okay. So what is this? 1 into 5R by 2?
Pi r by 2.
Yeah. Into 300
Yeah,
minus.
minus 450.
450.
Yeah. So whatever you will get in the terms of R. So calculate it and get your answer. So is this sum easy?
Ma'am,
Yeah.
here we're calculating from CA, na, ma'am. Then temperature could be 450 minus 300.
Yeah, you can write like that also. If you are writing it as AC, you can just reverse it. Okay.
Yes.
Okay. Is this part clear? Everyone, whatever sums we have done just now.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now read this. Whatever sums I am making you do, na, these are considered to be the toughest sums. Okay. So once you understand this, rest of the sums, I think you can do it. 0.5 moles of each of two ideal gases, A and B, CVM are given, are taken in a container and expanded reversibly and adiabatically. During this process, temperature is decreased from 350 to 250. Find delta H. So this is our T1, this is our T2. Okay, so this is what it is given here. Apart from this, what it is given, let's write A and right here. B. So what are the things which are provided to us? For A, CVM is given as 5R by 2. For B, CVM is given
3r
as
by 2.
PR.
3r by 2.
No 2. This is only
Yeah,
3R.
sorry.
So if CVM is less, what is CPM? CPM minus CVM is equals to R. So obviously it will be 5R by 2 plus R. 7R by 2, right? And what is the CPM here? 3R plus R,
4r.
4R.
right? So this is what it is given. Now they have asked to calculate delta H. What is the formula for delta H? N CPM delta T. Last class, I told you how to calculate CPM for mixture. Remembered? I told you to calculate, I gave you a formula like N. This is for the CPM for mixture. Like N1 CPM1 plus N2 CPM2 divided by N1 plus N2. This is how we calculate CPM for mixture of the gases, right? Remember this formula?
Yes, ma'am.
Good. So just now put the values. What is N? 0.5 into N1. What is N1? 0.5 and CPM 7R by 2 plus N2. What is N2? 0.5. into 4R. Right. And what are the values? 0.5 plus 0.5. What is delta T? T2 minus T1, 250 minus 350. Okay, so just you can calculate and get the answer. Okay, is this some easy? Yeah, so is this some easy? Did everyone understand what I did?
Yes,
Yes,
ma'am.
ma'am.
Just once look at this sum.
Ma'am,
Yes.
have you, I think, I don't know why did you take AR CVM, but I think what I CVM minus R equal to CPM, has you taken that formula here?
Yes, CVM minus
Okay,
CPM is equals to R. That formula.
okay, ma'am.
Just see and let me know. Any other doubts? I guess no. Can we move to the next sum?
Yes, ma'am.
Okay. See. An ideal monoatomic gas undergoes a pressure in which P by V is equals to 1. Find molar heat capacity. Molar heat capacity, I told you that this is something for JE people, JE advanced people. This is an IIT sum only. Okay. So P by V is equal to 1. What can we write it like this? P V to the power minus 1 is equals to 1. That is, P V to the power minus 1 is a constant. Can we write like this? Can we
Yes, ma'am.
write like this? Yeah. Now, if you start solving the question like P V to the power gamma is equals to constant, you will be wrong. Why? Why did I say you will be wrong?
Because we should have raised to as negative, ma'am.
No. They have asked us to calculate molar heat capacity. This, wait, I'm showing you. What is the sum? Molar heat capacity. What I wrote in the bracket, molar heat capacity is used for polytropic process. What is the general formula for polytropic process? P V to the power n is constant. Understood? Where people make mistakes. Did you understand where you made the mistake? So here we will be using the formula P V to the power n is constant. Okay.
Yes, ma'am.
Don't make this mistake ever again in your life. I'm marking it as start. Okay, now comparing these two equation, what can we write? N is equal to 1 minus 1. Right?
Yes,
Right or
Yes,
wrong?
ma'am.
Now, what did they asked us to calculate? Molar heat capacity. Last class, I did derive a formula with you. We will be using this. You remember the formula? It is C is equals to CV minus R by N minus 1. Just put the values. What is CV? What is the value of N? In your exam, exactly this was given. They didn't calculate 2R also. They wrote just this only. Okay, is this part clear?
Yes, ma'am.
Yeah, say. Any doubt, anything? Anyone wants to ask me anything?
No, ma'am.
Whole thing is clear, right? Okay, good. Now, write this. What is this? It is a JEE advanced question. At 5 into 10 to the power 5 bar pressure, D means density. Density for diamond and density for graphite is given. Acha, do you know we get diamond and graphite both from carbons? These
Yes,
are
ma'am.
the two forms of carbon only, diamond and graphite. Okay. So, okay, and one thing I guess you don't know, 1 bar is 10 to the power 5 Newton plus per meter square. Okay. Okay. So can we just start with the sum? They have asked us to calculate this. Okay. What we know the formula for delta H and delta U? Right? So delta H minus delta U will be equivalent to P del V. Right? Right or wrong? Yeah, say something. Up to this, it is clear, right? To everyone?
Yes, ma'am.
P means pressure. What is the pressure given? 5. Now, we will be converting this into Newton per meter square. That is 5 into 10 to the power 5 into 10 to the power 5 Newton per meter square, right? 1 bar is this much. So, obviously, this much bar will be this much, right? So, 5 into 10 to the power 5 into 10 to the power 5. Okay. Now, what is delta V? Delta V means V2 minus V1. Right or wrong? Okay.
Right.
So, 5 into 10 to the power 10. Now, density.
Mass by volume.
Yes. Okay. We need to calculate volume.
Mass
Yes.
by density.
Mass by density. Okay. So, what will be your V2? What is mass? What is the atomic mass for carbon? 12. What is the density given? 3.
Three.
Is this step clear to everyone?
Yes, ma'am.
Yes, ma'am.
So now can we just solve this? What will be it? Okay, so this is gram per cc. Now we are converting it into molar. So this is for 10 to the power minus 6. Okay, now we will just solve and get the answer in kilojoule. So it will be like 5 into 10 to the power 4 into 4 minus 6. So it will be minus 10 into 10 to the power 4. So that will be equal to minus 10 to the power 5. So it will be minus 100 kilojoules. So your delta U minus delta H will be 100 kilojoule. Okay. This is the type of the sum. This is the JEE advanced sum. Okay. Is this part clear? Whole thing?
Yes, ma'am.
Okay. Why did I do this? See, we are getting this in gram per cc, right?
Grams, ma'am. Yeah, ma'am.
gram per cc is equivalent to 10 to the power minus 6 meter cube. Because we have considered this in meter, so obviously we need to convert it. Okay, so is this part done? Is this part clear to everyone? Let's move to our final sum. What our final sum is saying, this is the easy sum. 1 mole of an ideal monoatomic gas, first keyword, expands, second keyword, adiabatically, third keyword, initial temperature T, against constant pressure. What I told you constant pressure means? Right? And we now need to just, so you know everything. You know the constant pressure, you know adiabatically. So you will use the formula for adiabatic irreversible process, which is NCVM delta T is equals to minus P external V2 minus V1. Okay, is this part clear? We are using directly adiabatic irreversible process. Now what is thing? 1 mole given. 1. What is the CVM of monoatomic gas? 3R by 2.
3R by 2, ma'am.
Yeah, and what is this delta T? Okay, we need to calculate final temperature only. Initial temperature is given as T, okay, not T1. Is equals to minus P external is 1 atm. And what is V2? V2 is 2 liter. 2 minus 1. Easy. Just solve something. T2. Like this, you will get the answer in terms of R and T. Okay. You will solve the question and you will get the answer in terms of R and T. So is this sum clear? So is whatever sums I made you do so far, is the sums clear? Is the logic clear how to solve the questions in thermodynamics? First, search for keywords and then accordingly put the formula. Bas, that's all you have to do. For your boards, you have to study the derivations. For your NEET or JU, whatever you are giving, you don't have to study the derivations. You only need to study the formulas. Okay. So is this part clear? Whole thing up to this?
Yes, ma'am.
Any doubt, anything? We have done a lot, right? We have studied a lot. We have done a lot. Okay. Okay. So should I just make a memory table for you, whatever the formulas we have learned so far?
Yeah, ma'am.
Okay. See, I'm not making the general formulas for work done on the system, by the system, isochoric, isobaric. No, I'm not doing that. So for work calculation, from work calculation, I am starting. Okay. So what is the graph for isobaric, isochoric, isothermal? They all are already written in my notes only. So here we will just be dealing with the main formulas. Okay. So first tell me what calculation? Work calculations. What is the first formula? What is the basic formula?
W equal to minus P external.
P minus P.
Yeah. Work is equals to minus P external of dV. Remember, we always consider P external just for reversible process. Since P external is equivalent to P internal, so we calculate the work considering P internal. Okay. Now, next, what is the next thing we have learned? We have learned about the units. I am not going to the units. So, for isothermal. So for, okay, let's do the isothermal in later parts. Isochoric. Okay, first write isothermal. Let's go sequentially. The isothermal. Now, isothermal has two parts. So, what is the formula for irreversible? Minus P external nRT 1 by P2, everyone forgot, by 1 minus 1 by P1. Okay, what was the formula for this? Minus 2.303 nRT
log P
log
one
of
V2 by V1
for 1, V2 by V1, or minus
2.303
2.303.
nRT log P1 by P2.
Yeah, this is the thing we have done, right? Now, what was the formula for isobaric? We have to use the basic formula.
Yes, ma'am.
And delta. What is the formula for isoporic?
Ma'am, it's 0.
0, ma'am.
0. Very good. Yeah. What was the formula for open container?
Ma'am, it's minus Ng. Minus delta Ng RT. ma'am.
Yeah, good. Okay. And what was the for cyclic?
Plus or minus area enclosed by PV.
Not minus area, it is just area enclosed by the. If
Ma'am, I
the
think we.
arrows, if the arrows are in the anti-clockwise direction, then you will use the positive sign before this area. If the arrows were in the clockwise, then you will use the negative sign before the area. Right? Right? Right or wrong? Is your teacher correct or wrong? Right or wrong? Right or wrong? Just say.
Right, ma'am.
Okay. So then we started with enthalpies. Okay, we have learned a lot in enthalpy, right? We have learned the basic formula. What is the basic formula? It can be either delta PV or it can be or right? In either of these three, we can use it. If I consider it both, this formula can also be written as nRT. Right? Up to this clear? And I have told you also what values to consider, what values to not consider, and so on. Okay? Then after this, what we have done, we have calculated the heat capacities. Right? Should I write the heat capacities? Because heat capacity is something I have already written below, before. Heat capacities. Heat capacities are a lot of things. First was the total heat capacity. Second comes our molar heat capacity. This is the molar heat capacity. Third comes the specific heat capacity. Fourth comes our CP, heat capacity at constant pressure. Fifth comes our CPM, molar heat capacity at constant pressure. Next comes our CPS. This is specific heat capacity at constant pressure. Then comes our CV, heat capacity at constant volume. Then comes our CVM, next comes our CVS. What was this? Specific heat capacity at a constant volume.
Plus QV by delta W to delta T.
Yeah. I made a mistake. Okay. So these are the things we have learned. Okay. Now we have also learned, I'm writing in the next page. What we have learned? CPM minus CVM is equal to R. What we have learned? CP minus CV is equal to NR. Okay. N is the number of moles. Okay. Then we have learned CT is equivalent to NCM is equal to WCS. Next, we have learned CM is equal to molecular weight into CS. Next, we have learned for the isothermal. Okay, let's write. For isothermal process, your C will be equivalent to infinity. For isobaric process, your C will be equivalent to CP. For adiabatic process, oh, very good. Your C will be equivalent to 0. And for isophoric process, your C will be equivalent to CV. Right? Next, for mixtures. What was the formula? CVM for mixture. N1 CVM1 plus N2 CVM2 plus ... N1 plus N2 plus ... Considering how many gases you have. CPM for mixture. What was the formula? N1 CPM1 plus N2 CPM2 plus ... divided by N1 plus N2. And what was the Poisson's ratio? Gamma. So gamma is CPM
by
of mixture. Yeah. Say. Of mixture, right? We have solved sums regarding this also. So up to this, does anyone have any doubt? We did this. Then I'm not writing it. Then we have calculated degree of freedom for monoatomic, diatomic, triatomic, linear, and non-linear. Right? We have done this. Okay. Then we have started with the adiabatic process. See, here. Here also in the word calculation, you can write the adiabatic process. But since adiabatic process is a separate chapter, I am doing it like this. Okay. So first, we have learned about relation between P, V, and T for reversible adiabatic process. And I told you repeatedly, this is only for reversible adiabatic process. So what were the three formulas we have learned here? T v to the power gamma minus 1 is constant. Then P v to the power gamma is constant. And also P to the power 1 minus gamma into T to the power gamma is constant. Second, we learned about word calculations. And I told you for adiabatic process, for reversible and irreversible, they will not give you the final temperature or the initial temperature. You have to first calculate the final temperature or the initial temperature which is not given. Then you have to calculate the work done. Okay. So, what I told, you have to calculate final or initial temperature. Before calculating work done. Secondly, use formula to calculate work done. Okay. So for adiabatic process also, you have two things, irreversible and reversible. So what is to be done for irreversible? 2A, irreversible. To calculate temperature. Temperature, final or initial, whichever is not given. Final or initial. What formula did I ask you to use? What was the formula? And to calculate the work done, then what formula you are going to use? Okay. See, if the temperature is already given, T2, T1 is both mentioned in the question, you will use this formula. For reversible, to calculate temperature, maybe final, maybe initial. What you have to do? You have to use either of those three formula. And to calculate the work done, you can use two formulas, NCV delta T, or you can use that formula, P2V2 minus P1V1 divided by gamma minus 1. Okay, or you can write it as delta PV by gamma minus 1, or you can also write it like NR delta T by gamma minus 1. All these derivations have been done. Up to this clear? We had to use what formulas?
Yes, ma'am.
Yeah,
Okay.
ma'am.
Last was the polytropic process. For polytropic process, what was the formula? PV to the power n is equals to constant. N can never be 1. To calculate, okay, wait, sorry. And I told you also, what is the interpretation for this? N is equals to 0 means if n is equal to 0, then P is constant. Okay, which means isobaric. If n is equal to 1, then PV is constant, which means isothermal. And if n is equal to gamma, then PV to the power gamma is constant, which is adiabatic. Okay, now what is the formula for calculation of work done? Work calculation. What was the formula? What was N? N is the number of moles. You can also write it like NR delta T by N minus 1. And for the same polytropic process, what was the molar heat capacity formula? C is equals to CV minus R by N minus 1. Okay. And something I told you today, not from this, something I told you in today's class, that always use the general, whatever formulas I have given you, whatever the formulas I have given you so far, use those formulas only to calculate the work done for respective process. But if it is written work done on system, means it is a compression work. And you will get the answer. I am writing. You will get answer in positive. Okay. And if it is said work done by the system, it means expansion work. You will get the answer in negative. Do not put signs in the general equations which are derived in class. Like what I'm asking you, that if you are using, suppose you are calculating work done for isothermal reversible process, okay? So you will be using this formula only. You know that it is a compression work. Don't put here plus. you will get the answer in plus. The values will automatically be adjusted. Okay. So is the whole part of the thermodynamics clear up to this? I have to tell you more in next 2-3 classes I will do. Up to this, is it clear?
Yes, ma'am.
Yes,
So
ma'am.
now you can just solve. So now you can sort out where to put. We have done a lot of numericals, right? Right? We have done a lot of numericals. So now are you gaining confidence? Are you gaining the confidence that if we practice, we can solve? Are you gaining this confidence? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So this was from my end. And tomorrow I will not take any class. Day after tomorrow, I will take. Okay. So I will be sending you this PDF. Go through this. You have a whole day to go through this sum. Numericals, whatever we have done, whatever the things I asked you to note down. And in this summary, there is not everything written. Something is written while doing the, more things are written while doing the sums, right? So, but okay, something I have to tell you. Here you have to put plus or minus. Okay. This is the whole formula. You will be putting plus or minus, that depends. Don't get confused with this. Here you always have to take minus, minus, or whatever the formula is. Okay. But here you have to take plus or minus depending on the errors. Okay. Just practice the sums, and if you feel any doubt, you can ask me in the next class. Okay. Okay. So, ma'am, this was from my end.
Yes, ma'am. Thank you, ma'am. స్టూడెంట్స్ మళ్ళీ రేపు మార్నింగ్ క్లాస్ ఉంటుంది 5 to 7. ఓకే, నేను లింక్స్ గ్రూప్ లో షేర్ చేస్తాను. బాయ్ ఎవ్రీవన్. అగైన్ విల్ మీట్ టుమారో.